In this video, we will assume that you already know how to use the standard normal table. A personal computer is used for office, work, at home, research, communication, personal finances, education, entertainment, social networking, and a myriad of other things. Suppose that the average number of hours a household's personal computer is used for entertainment is 2 hours per day. The average is the mean. Assume the times for entertainment is normally distributed and the standard deviation for the time is half an hour. Find the probability that a household's personal computer is used for entertainment between 1.8 and 2.75 hour per day. The statistic given is for the number of hours used for entertainment purpose. We were told that this is the normal distribution. If we let x be the number of hours used for entertainment purpose, then this is the normal distribution. So we draw the normal curve. Always draw the normal curve for the normal distribution. From the peak down, look at the mean. The mean is mu 2. The mean is the average. The standard deviation is 0.5. To answer this question, we first put this probability in symbolic form. We're looking for the probability that, remember that x is a random variable that represents the hours used for entertainment. Then we're looking for p of 1.8 less than x less than 2.75. It does not matter whether we use less than or equals in this case because this is a continuous distribution. We cannot use the table right away because the mean is not 0 and the standard deviation is not 1. This is a normal distribution, but this is not a standard normal distribution. To answer this question, we need to change or convert this into the z-score. And so remember that the standardized formula is z equals x minus mu over sigma. X are the given values. We need to standardize two values here. For x equals 1.8, the corresponding z-score is 1.8 minus 2 divided by 0.5. This will give us negative 0.4. So negative 0.4 goes here. For x equal 2.75, the corresponding z-score is 2.75 minus 2 divided by 0.5 because the mean is 2 and the standard deviation is 0.5. This will give us 1.5. So 1.5 goes there. Lower, negative 0.4 z-score, and upper, the z-score of 1.5. From the graph where we label the mean of 2 and the standard deviation of 0.5, we would label x 1.8 and x 2.75, and we're looking for the area in between. But again, we cannot use the table because this is not a standard normal distribution. But after we standardize this, we now have the mu 0, sigma 1 with the two corresponding z-score, negative 0.4 and 1.5, not drawn to scale. However, the negative is on the left-hand side of the mean and the positive z-score is on the right-hand side. To find this area using the table, we first find the area on the left-hand side of the larger z-score, and then find the area on the left-hand side of the smaller z-score. For the z-score of 1.5, the area or the probability on the left-hand side is 0.9332. For z equals negative 0.5, the area or the probability on the left is 0.3446. These numbers come from the standard normal table where the mean is 0 and the standard deviation is 1. To find the area in between, we take 0.9332, subtract 0.3446 to get 0.5886, and that is the probability that we're looking for between the hours 1.8 and 2.75. Next, find the maximum numbers of hours per day that the bottom quartile of households use a personal computer for entertainment. Again, we need to draw the graph for the normal distribution with the means of 2, standard deviations of 1. This time, though, we're looking for the score that separate the bottom quartile. Quartile is 0.25, that is a 25%. We're looking for this number x that would separate the bottom 25% and the top 75%. And the formula that allows us to do so is x equals mu plus z times sigma, where x is unknown, mu is 2 plus z times the standard deviation, sigma 0.5. We have everything we need except the z-score. But with an area on the left-hand side being 0.25, we can find the corresponding z-score. The corresponding z-score is negative 0.675 from the standard normal table. And so the score that separates the bottom 25% or the bottom quartile from the top is 2 plus negative 0.675 times 0.5, and this will give us 1.66.